Hi guys, this is a revision of this thing. Nope, not that thing. This thing right here. This is a revision of my little doubler box. I'm going to remove that, and I'm going to keep that just for testing purposes. That is not something that you want to run long term, because it's, we have 15,000 volts at the anode, and I've got 10,000 volt caps in there. This will work short term, but that's too much. You're stuffing, it's like stuffing a, I don't know, 5 pounds of sausage in a 4-pound bag. It just doesn't fit. Kind of the same thing, if you will. Too much voltage for those caps. Those are 10,000 volts rated, and you got 15,000 out. So what I did is I've upgraded. These are 20,000 volt capacitors, and these are 18,000 volt diodes. Now you remember the diodes that I used in here were rated at 12,000 volts. Once again, I want to use diodes that actually cover the whole voltage, right? If this, which these probably were fine, because if this thing's outputting 7,000 to 8,000 volts, those 12,000 volt diodes would have been fine. But to store that high voltage charge of 15,000 volts, we need our capacitors to be a little better. And then what also concerns me, if you look at the schematic of this, which I don't have it here. Let me see if I can draw it out really quick. You have your high voltage transformer right here. And then we have a capacitor, diode, and then this goes to another diode like this, I believe. And that's ground. Let's call this ground. And then we have another capacitor here going to ground. And this is your out, right? I believe that's right. No, that's not right. That's not right, because this one's got to be the other way, I would think. Like this. That way, when this is positive, this is forward bias, and this is not forward bias. Yeah. Okay, so if this has 15,000 volt charge on it, and this is a 12,000 volt diode, peak reverse bias or whatever, that 15,000 is really putting a lot of pressure on this, right? So I want these to be able to at least handle what's on the output. So I've upped this to an 18,000 volt diode, and these went from 10 kV to now 20 kV. So both of the diodes are 18 kV, both of the capacitors are 20,000 kV. That is our circuit. Okay, so yeah. All right, so I'm gonna. I bought 2 extra. It takes 2 and 2 for each circuit. I bought 2 extra just to have, if I needed to build another one in the future. But yeah, so I'm gonna go ahead. I've got this. I think, yeah. This is a soap box, Dove soap, that I've kind of cut, and I'm going to build this in this. And solder this into the thing. So that's what this is going to go in. And I think these were, these capacitors are maybe $2.50 a piece, maybe close to $3. So, and the diodes are like $2 a piece. So you're looking at about $10 in parts. The most expensive thing to do in this is the epoxy. The 2-part epoxy is the most expensive part of this. So we're going to build this down into here and then cover it with epoxy. Just like I did with this one. Except I want this. I made a mistake and I want this over here. I'm going to orientate it different so that this comes out in this corner instead. So it'll be new and improved. And since it's Dove soap, it's going to smell wonderful. And this is the circuit. You have your input right here, goes in through the capacitor, and you see the other leg of the capacitor is hooked to the anode and to the cathode of a diode. And you can see that here. The capacitor is connected to both the anode and the cathode of different diodes. And the one that it's connected to the anode, that is the output. So here's where it's connected to the anode, and then you have it output right here. And then that goes through a capacitor to ground right here. It's through a capacitor to ground. And the other diode, the anode, is grounded. And that's right here. The anode is through the ground right there. Those are your 2 ground spots right here and here going through the bottom. And then you have your output and your input. And got a cup here. That's just one. Here's the original. I got one that I've cut off of a flyback. For all of you that are watching this that replace flybacks or whatever, if you would, do not throw them out. Clip this off and send it to me, because I can always use these to do this. So if that's something that you would do, that would be great. Get with me in the comments if you have dead flybacks with anode cups that you can donate for this purpose going forward. So yeah, so I'm going to fill this thing up with epoxy, and that'll do it. Nice little circuit laid down in there. Okay. Alright, I got my 2 packages of 2-part epoxy, and I get them with this mixing tip. See, comes with a mixing tip, so you just empty it out into there and it mixes. And I put that over it to kind of level it so that it cures level. But everything's covered up. It doesn't look it, but that is submerged. And then you have your little lead coming up. That's your input. And yeah, we are covered up with proper parts. I'm going to let this cure overnight, and tomorrow we'll come back and put it in there, and we should be good to go. Okay, it is the next day, and this thing is solid. We have our lead coming up right here for the input. Obviously this is the output, sealed nicely in the epoxy, and our 2 ground leads coming out. So there you go. There's our doubler. So we'll go ahead and install it in here and get everything all hooked up. Just put this one aside. I'm going to keep this one for whatever, I don't know. Anyway, let's go ahead and install this guy and get it all hooked up. Okay, there we are, all installed. Kind of hooked and soldered there. That's your input. And your output coming out here. And the 2 grounds soldered through there. So we're good to go. Let's hook this thing all up and make sure, just test it out. Should be fine. Basically, we're going to check and make sure I soldered the circuit together correctly. Well, and there it is. Perfect high voltage. The monitor looks great. There's our little soap box with our doubler circuit. I'm not even going to bother measuring the high voltage, but yeah, because I'm sure it's fine. There you go. You know what, I got that new tool. Maybe I will go ahead and measure it and just make sure. It should be about 15,000 volts. I'm sure it is. It looks exactly the same as it did when I had this one installed. So I'm confident our circuit's good. But it looks great. And now it's got parts in that doubler that are rated above the high voltage. So very happy about that. Yeah, so if you do replace like G07 flybacks or whatever that go out, save the anode lead so that they can be used for this very purpose. Because that's what this one's from. I believe this is a G07 anode lead that I had saved. And it works perfect for this purpose. Yeah. Beautiful. And there you have it. What I'm going to do is I'm going to go ahead and just kind of tack this portion of the video before the original video that I did. So it'll be one long video. You'll have the updated part of it first, and then the original video that I made will be after that. So I think what I'll do is I'll go ahead and download that video, and then in my editing software I'll add this first part before that and make it all one big video, re-upload it as one video. So there you have it. That'll do it for this one. I'll go ahead and let this thing run for a while. And yeah, monitor high voltage repair. My Asteroids board back there. Bootleg Asteroids board. Alright. Thanks for watching, and we'll see you all on the next Classic Arcade Repair. Hi guys. Today what I'm doing on Classic Arcade Repairs is I'm showing you, this is a high voltage cage out of a Electrohome G05-801. Now, these vector monitors came in the early Atari stuff like Lunar Lander and the early run Asteroids games. And these are not interchangeable with the more common G05-802-805. You know, the 801 was engineered different. It's a totally different circuit, really. It uses a voltage doubler. This thing right here. This essentially doubles the high voltage from the winding in this and sends it. It doubles it and sends it to the tube. And these things are a common failure on these. And this one had failed. This was a job that I did. I don't record every job that I do. This is a monitor repair that I got in. And this is the first time I've experienced and ran into this particular problem, so I figured I would film this part of it. By the way, who else loves Boston baked beans? This is an off-brand called Burnt Peanuts or something like that. But they're essentially Boston baked beans. These things are the bomb. Super crunchy, but delicious. Yeah, so I'm coming up with a solution to double the high voltage out of this thing to send to the tube. To replace this, essentially I need to replace this. Yeah, so I will show you the solution that I am using to do this. Let me come back. I'm going to go grab a schematic and we'll look it over and then show you the parts that I'm getting and all that good stuff. Okay, yes, and this is essentially the diagram in the schematic for the 801-801 vector monitor. Is it has off of the high voltage winding, it just has a square that says doubler, and then it has a ground coming out of it like this, and then an output going to the tube. This is the circuit that I'm going to use to double that. Now these are, the capacitors are 10,000 volt capacitors, and the diodes are 12,000 volt diodes. You know, this does not really carry any current. It is way down in the microamps. So they don't have to be heavy duty parts. Just have to be the proper rated voltage. And I have right here my parts. There's my two high voltage 12,000 volt diodes and my two 10,000 volt capacitors that I'm using. And if we look at this, there's a little bit of charging capacitor diode magic that goes on in this. A lot of electronics, honestly, a lot of electronics just seems like magic how it works. But nonetheless, it works. On the upper, you know, you have a sine wave coming out of this. You have a sine wave, you know, going up and down like this. The top half, when it's positive, when this is positive here, and this is negative, current is going to flow this way. This current flows from negative to positive. So if this is negative right here, if this is negative, and this is the positive side of the wave, current is going to go through this capacitor, through this diode. Okay, this one is reversed biased, this one's forward biased. So current path is going to be like this, and it will charge this capacitor. And then when polarity flips, and this is negative, the current is going to flow. If this is negative and this is positive, well, when this goes negative, this one will be forward bias. So current is going to charge this and go this way. So this capacitor will be charged, and then somehow when it flips again and this is negative and current does this, somehow the energy that's charged in this capacitor and the energy that charges this capacitor on that wave come together right here in some kind of magic, and this is going to have a double charge on it right here. Yeah, it's hard to explain, it's hard to imagine and see it, but that's just how it works. It's some kind of charging magic. When this thing charges and then it discharges maybe through this diode or something, and anyway, the double charge ends up right here at this point. So yeah, I never claimed to be a teacher, guys. This is just, you know, a basic understanding of this. This will work. So that's how I'm going to wire this up, and I'm going to use this box right here to put my, this is a lip balm box that I got from my neighbor actually. As I was asking around for little boxes, cardboard boxes like this, and my neighbor had this lip balm box, so I got that, and I'm going to put my circuit together. I'm going to put it into here. I'm going to actually mount this thing in here with the holes, and I'm going to take a little bit through the bottom and drill holes into this so that I can mount my ground leads coming out. I'm going to have my 3 ground leads coming out. of this, and I'll be able to solder. This is going to be a little block. I got some 2-part epoxy. I got a couple of them with a mixing tip. So I'm going to put the mixing tip on, and I'm going to put my circuit down in here with a couple leads coming up. You know, my input and my output, and my ground's going through the bottom. I'm going to fill it with epoxy. I'm going to let it harden, and then I'm going to try to get this cardboard off of it. So all I have left is the square like this. I just want a square left over of epoxy with my parts encased in it so that I can solder it into there. And yeah, I'll have to do something about this. I want to have this, you know, in the epoxy, kind of like how this was. So I'll have to do something, you know, figure out how I'm gonna, you know, I'll take care of that, and maybe I'll have to lengthen this a little bit, maybe with some solid core wire or something. I'll figure it out, but that is the plan. So I'm gonna go ahead and get my circuit built nicely and neatly so that I can hide it down in there, and yeah, we'll see how it looks. Yeah, by the way, I just got to looking at this. I had drawn a square and then just kind of made this circuit inside of here. You cannot do this like this. This cannot be connected to this. This cannot be connected to that. Okay? And for that purpose, let's say that this is not connected. This is the outer boxing, let's put it that way. This is the only part of the circuit. This is your 3 ground points. And you can see there are 3 ground points in this thing. The 3 holes, those are the ground points. So that's your 3 ground points right here. 1, 2, and then you can put them together and have a third. I'm just going to do these two, this one, and I'll probably do this one as well. I'll probably do 2 grounding points. So you have your input from the transformer right into the 1 capacitor, and then this is not connected to ground. It's not, you know, that would be a little disastrous. So this outer lining is not connected to nothing. There you go. So if you're attempting to do this, do not connect that. This is the circuit right here. Okay. That's it. None of this is connected. Just wanted to point that out, because that, you know, that would have been bad if someone would be trying this. Yeah. Okay. Just wanted to let y'all know that. Do not connect these points. Okay. Alright, here's a simplified drawing. I should have done this one in the first place. There's your simplified drawing. You see the one end of the high voltage transformer is grounded. So your current path into this doubler is through ground, you know, of course. And yeah, so that's it. You'll have these 2 elements grounded. You got 2 ground points. That is it. Okay, we are clear. Okay, I just kind of lined this thing up. You see the holes in it. I just kind of lined it up with this footprint, and from the back side I held it. And then from underneath I used this little drill bit to drill up, just hand drill up through it. And I made my grounding holes. So I'm going to go ahead and build this circuit And we'll test it with like 120 volts or whatever and make sure we get our doubled voltage. Or we'll put whatever, you know, a 12 volt. I'll put a 12 volt AC on it, just make sure it doubles it, and then we'll be good to go. 12 volts might not even work with this. We'll see. All right, here's my little box of circuit. I got the out labeled. I got the in labeled. See a little lead coming out. I got my grounds through the bottom, and the circuit is in here. It ain't exactly beautiful, but it's wired according to that. So I will fill this with epoxy and let it, let it cure. And we'll be ready to try it out. Okay, and here is the end result. It is the next day. This stuff is a little sticky, but it's pretty solid. Get your two leads coming out the bottom. It's just a block of epoxy. Now this here, what I had done was I covered that joint in a white silicone sealant, and then I slid heat shrink over it and shrank it, so that joint is covered in a silicone sealant. You can see it, the residue of it right there, the white there. So that's sealed good. I almost would like to put some more epoxy to cover that a little bit, but it's pretty solid in there, and everything's covered, so I think we're just going to roll with it. But yeah, so next thing is to mount this in that high voltage unit and give it a shot. Yeah, you can see the two caps, the two capacitors encapsulated there with the lead coming out right there. That's your input. Obviously this is the output right here. Yep, so that's that. There is my makeshift voltage doubler. And it is working. I mean, as far as the size of the screen, it's not all blown out and huge, but this is as bright as it'll go. Now, I'm kind of thinking that this is not a high voltage problem, but it could be. We could have just low high voltage, but high enough to make it look right as far as the deflection. As before with the bad one, it was like blown out. Everything was off the screen. This little guy, the saucer was giant, like this big going across the screen. So everything was really blown up. Now it's the proper size, but it's just really dim. And that's as bright as it'll go. I wish I had a high voltage probe so that I could see the high voltage output, but I don't have that. I don't have one. I think I might have to get one so that I can pop it under that cap and see what kind of high voltage we actually are getting, because we should be getting around 15, I guess 14, 15, 16,000 volts or something like that out of this. And I kind of think that we might be, but I don't know for sure because, yeah, I don't have a probe. So I can look at stuff on this board in the brightness circuit. I can surely take a look at the voltage going, the 6.3 volts going to the neck tube. That could be low, right? So there's some things that we can look at. So let's do that. Let's just look at a few things. Okay, I'm back to the high voltage, or the monitor. I've been away from this a little bit because I had to buy a new toy. I had to buy this guy. This is a B&K Precision high voltage meter. And I put this nice slip under the cup anode tip on it. And it just reads out high voltage. It's got a clip coming off of it that you just put to the frame. And slide it under there. There's my, remember my epoxy box that I made? So let's go ahead and use this thing. You want to? Okay. Just make sure this isn't touching nowhere near this ground. And we'll come in. There we go. And I don't know if I'm getting this. I think I am. You see, it's about 15,000 volts. I'm going to go ahead and take this out now. So yeah, this thing's awesome, by the way. But my fixed that. That's 15,000 volts. That's absolutely perfect. That's right in the area of what it should be. So this is not a high voltage issue. This is a deflection board issue that I got to figure out, I believe. So back to the drawing board, but I needed to get that so that I could eliminate that as a problem. So yeah, made a nice voltage doubler out of those little diodes and capacitors. Boom, done. Okay, well, we'll see what we can figure out. Well, looky there. The issue turned out to be a bad brightness pot. So I put a new one in there. It's not the correct form factor, but I adapted it. Yeah, so there you go. That's it. Go ahead and move the yoke a little bit to straighten it out. Oh yeah, looks pretty good. I'm going to go ahead and let this sit and cook for a little while, let it run. But yeah, there's a good fix for that pesky voltage doubler when it goes bad. So you can see that works absolutely great. That's going to do it for this one. Yeah, so what did we do? It's been a while because I had to buy that thing. This was not cheap. This baby right here was 125 bucks. But this thing had a bad transistor, and then I removed all of the transistors, put new micas under it, and new heat sink paste. And I had to replace one of them. I recapped this, reflowed all the solder, new pot. I replaced all of the pins in here, the pin connectors, the Trifurcan pin connectors in all of these. That guy needed the voltage doubler, and I recapped it. New caps. This thing had a bad blown fuse. I removed both of these transistors and put new micas underneath and new heatsink paste. Reflowed all the solder that needed reflowed. I replaced those two capacitors. And I guess that's about it. Reflowed all of the solder that needed reflowed on everything. And yeah, I guess that's it. Alright, yeah guys. Another monitor repair done and a high voltage unit saved. Thanks for watching, and we'll see you all on the next Classic Arcade Repairs. Bye for now.